I've got to say, guys, bearings questions like this are definitely not the most intuitive. So if you haven't seen one before, make sure to pay very close attention to this key skill. The question says that Sarah is 8 kilometers west and 3 kilometers north of Laura. So 8 kilometers west and 3 kilometers north of Laura. Let's just write those two distances in, 8 kilometers west and 3 kilometers north of Laura. The question says, what is the bearing of Laura from Sarah? The bearing of Laura from Sarah. How are we going to think about this, guys? Well, the first step is going to be to draw a straight line connecting Laura and Sarah. That's not a straight line. That is a very curved line. Let's do that again. So Sarah and Laura. The bearing, guys, remember we measure bearings from the north line. So the bearing is going to be this angle here. Let's call it X for now. So how are we going to do this? Have you got any ideas? What we're going to do is we are actually going to use trigonometry to help us. We're going to turn this little situation down here into a right angle triangle. That is going to allow us to work out this angle here. We know that this is going to be a right angle, and that's going to allow us to work out this angle here. Or to be honest, we can actually just work out this angle here directly. And then we can subtract it from 180 to find the size of angle X here. So we're going to draw a right angle triangle and then use trigonometry to find this angle here, subtract it from 180. Let's get it done. Let's firstly convert these two arrows that I drew into straight lines. So I'm going to draw a straight line from here to here. And then I'm going to draw a straight line from here to here. We're going to draw a little square here to represent the fact that it's a right angle triangle. Now we can use trigonometry. We can use SOH TOA to work out this angle here. If you're not sure how to use trigonometry, guys, make sure to watch my videos on SOH TOA because you're going to want to go through that before this one. So given this right angle triangle, how do we find the size of angle Y? Step number one, we're going to label our side lengths as either the opposite, adjacent, or hypotenuse. Let me switch to a little green pen just to make things a little bit clearer. Yeah, that should be better. So opposite the angle, we have the opposite side. Opposite the right angle, we have the hypotenuse, and our other side length is the adjacent. We write out SOH TOA. We have SO, CAH, and TOA, and then we need to decide which one we are going to use. In this case, we have the opposite and the adjacent, so we're going to be using the one which includes O and A. We are, in fact, going to be using TOA. What does TOA tell us, guys? Switching back to orange, TOA tells us that tan of our angle, in this case tan Y, is equal to our opposite side. In this case, our opposite is 8, divided by our adjacent side. In this case, it is 3. Next step to using SOH TOA to do this, guys, we're going to do tan to the minus 1 of both sides. So we're going to have tan to the minus 1 of 8 over 3, and that is going to be equal to, let's type it into the calculator, we have tan to the minus 1 of 8 over 3. Typing that in, what do we get? We are going to get 69.4 to 1 decimal place. How is this going to help us? Well, now we've found that the size of angle Y is going to be equal to 69.4. We know that angles on a straight line add to 180, and we actually see that we have a straight line up here between the X and the Y. Final step then is going to be to do 180, subtract our 69.4, 180 minus 69.4, that, guys, is going to be 110.6. Yep, 110.6. Guys, if you got that, superb work. Very tricky question there. Hopefully that made sense. We used trigonometry to find the size of angle Y and then subtracted it from 180 to find the size of angle X.